In this video, we're going to simplify expressions with rational exponents. Rational exponents are exponents that are fractions. Sometimes it's a little hard to tell when a fraction is an exponent, but if you look close at these, they're raised up a little bit and a little bit smaller. Let's review some of our exponent rules first. Here we are multiplying two exponential expressions with the same base. So this is really 5 times x to the negative 7th power times x to the 4th power. So the 5 just tags along. That exponent has nothing to do with that 5. And then since these exponential expressions here have the same base, we add the exponents. So 5x to the negative 3rd power, because negative 7 plus 4 is negative 3. Now let's not leave a negative exponent in our answer. A negative exponent has nothing to do with negative numbers. It just means that this expression is in the wrong place in a fraction, so we're going to move it down to the denominator. And when we do that, the negative sign goes away. That negative exponent has nothing to do with that 5 though, so the 5 stays in the numerator. Here we have 7 times z to the 10th times z to the 8th power. Once again, we add our exponents, and the 7 just tags along. So 10 plus 8 is 18. So 7 times z to the 18th power. Let's practice with our quotient rule now. And the quotient rule tells us when we have two exponential expressions with the same base, we can subtract the exponents. Now the 6 and the 4 here, these are not exponents, so we're not going to use exponent rules on the 6 and the 4. We're just going to simplify those. So we're going to divide the top and bottom by 2, because those are both divisible by 2. All right, 6 divided by 2 is 3, and 4 divided by 2 is 2. Now we're going to subtract the exponents. So we have 6 minus negative 2. Well, that's the same as 6 plus positive 2. So that equals 8. So that means we have k to the 8th power. This answer is perfectly adequate. It might look a little nicer if we wrote that as 3 halves times k to the 8th power. Okay, here we have the regular 8. So, and then we're not dividing the 8 by anything, so we'll just put that 8 up in the numerator, just tags along. Then we have 3 minus 13. Well, 3 minus 13 is negative 10. Right now I don't have anything in the denominator, so I'll go ahead and fill in with a 1. But these y's are in the wrong location. We know that because it has a negative exponent. So we're going to move y to the 10th down to the denominator. That 8 stays where it is, because that negative exponent has nothing to do with the 8. And the y to the 10th power moves down to the denominator. Notice that there are more y's in the denominator than in the numerator, and the leftovers are in the denominator. So that makes sense. Here we're raising exponents to an exponent. That 8's a regular 8 though, so we're going to treat it like a regular number. This will be 8 to the 3rd power, which is 512. So 8 to the 3rd power is 512. Z to the 4th power raised to the 3rd power. That's where we multiply our exponents, because we're raising an exponent to an exponent. So that's z to the 12th power. K to the 9th power raised to the 3rd power. Once again, we multiply. So that'll be k to the 27th power. And m to the 7th raised to the 3rd power. That's m to the 21st power. And here we're raising this expression to the 2nd power, so we just multiply those exponents. C to the 18th power times n to the 14th power times k to the 12th power. All right, let's get going with our rational exponents. We'll be using those same rules, but now we have fractions. The negative 2 and the negative 6 are just regular numbers. This is all multiplication, So we can multiply in any order we want. So negative 2 times negative 6 is positive 12. Now we'll multiply x to the 5/4 times x to the 3/4. So in this case, we're multiplying two exponential numbers with the same base, and we add the exponents. So let me just write that out here. 5/4 plus 3/4. Fortunately, we have common denominators here. Otherwise, we'd need to get those. Now the y's. Once again, we are adding the exponents here. So 3/2 plus 1/2. Simplifying that, we have, let's see, 5/4 plus 3/4 is 8/4. And 3/2 plus 1/2 is 4/2. Now let's go ahead and simplify those exponents. 8 divided by 4 is 2, so we have 12x squared. 4 divided by 2 is 2, so times y squared. Over here, we once again multiply our regular numbers, add the exponents. 2/5 plus 1/5 is 3/5, so x to the 3/5. And 6/5 plus 1/5 is 7/5. So I have negative 12 times x to the 3/5 times y to the 7/5, because in this situation we are adding the exponents. Here we have a division problem, so we'll be subtracting these exponents. The 7 and the 2, those are regular numbers, and we cannot simplify those. So we'll go ahead and fill those in. Then we have x to the 5/4 minus 1/4. And 5 minus 1 is 4, so that'll be x to the 4/4. I did 5/4 minus 1/4. And here we have y to the 1/2 divided by y to the 5/2. We'll go ahead and subtract those exponents. 1/2 minus 5/2 would be negative 4/2. That'd be one way to think of it. We don't want to leave that negative exponent in our numerator, so we're going to be moving these y's down to the denominator. 7 and the 2, those stay where they are. 4/4, that equals 1, so that's just x to the first power, or just x. 4 divided by 2 is 2, and it's a negative 2, so that moves down to the denominator. So we have negative 7x over 2y squared. Once again here, we will be subtracting our exponents because we have exponential expressions with the same base. The 5 and the 7 are regular numbers though, so we're not subtracting those. We cannot simplify those, so we'll just fill in with the 5 and the 7. Then we have 2/3 minus 4/3. That'll be negative 2/3. And 5/2 minus 3/2, that will be 2/2. Now at the negative exponent, these x's are going to be moving down to the denominator. And when we do that, the negative sign goes away. So we have the 5, we have the 7. The x's move down to the denominator. And the y's stay in the numerator, but let's go ahead and simplify that fraction. 2 divided by 2 is 1, which should be y to the first. But we don't need to write that 1 for an exponent. It looks nicer without an exponent. So we get 5y over 7x to the 2/3 power. And finally, we have some exponential expressions being raised to another power. This is where we multiply our exponents. Let's treat the 27 like a regular 27 though. All right, we have 27 raised to the 5/3 power. Well, let's rewrite that as a root. The denominator will mean it's the third root. And then we have our 27, and we're going to raise all that to the 5th power. So I'm going to put that on the outside of the root so that we figure out our root first, and then we'll raise that smaller number to the 5th power. All right, let's multiply our exponents here. 2/3 times 5/3. We multiply across the top and bottom and get 10/9. 2 times 5 is 10. 3 times 3 is 9. Multiplying across the top and bottom for the exponents with the m. 1 times 5 is 5. And 2 times 3 is 6. So m to the 5/6 power. All right, we have a little work to do here. We're wondering what number multiplied by itself 3 times equals 27. Well, that would be 3, because 3 times 3 times 3 is 27. So we have 3 to the 5th power, because the third root of 27 equals 3. Then we have times k to the 10/9 power times m to the 5/6 power. Let's work out 3 to the 5th power. $243. Okay, over here, once again, we will be multiplying these exponents because we have an exponential expression being raised to another power. But let's treat the 16 like a regular 16. So that'll be 16 to the 5/2 power. Let's go ahead and write that as a root. It's the second root, which is the square root, so we don't need to put the 2 there. We could, but it looks a little funny if we put a 2 there. It's just the square root. And then we're going to raise all that to the 5th power. So we'll do the root first to get that number smaller, then we'll raise that smaller number to the 5th power. Now we multiply our exponents. We have times m to the, 1/4 times 5/2. 1 times 5 is 5. 4 times 2 is 8. So m to the 5/8 power. And for the k's, we have 5/4 times 5/2. 5 times 5 is 25. 4 times 2 is 8. Looking at those exponents, we cannot simplify those, so we'll just leave them like that. But we can simplify the root. The square root of 16 equals 4. So this is 4 to the 5th power. Let's figure out what 4 to the 5th power is. $1,024. So we get 1,024 times m to the 5/8 power times k to the 25/8 power. I hope these examples about simplifying expressions containing rational exponents have been helpful. This is Mr. Ela, signing off.